Welcome everybody to today's FDTD GO16 applications webinar. We're pleased to have Pete Wolf from the Weather Service office in Jacksonville, Florida, joining us, and he'll be talking about GO16 observations of the sea breeze and also discuss wildfires. Go ahead to the next slide. First, a little protocol to go over. All these are recorded and available on the visit web pages at the URL that's shown here. Also, if you're interested in leading one of these in the future, just let myself, Dan Bicus, or Scott Lindstrom know, and our email address is provided there at the bottom. Next. Finally, we'll have about 20 minutes for our speaker. If you have questions, you can either send them via GoToChat, or we'll have a Q&A period over the phone after Pete is done talking, and we'll be done within 30 minutes. Remember, do not press hold and also mute when not speaking. So at this point, I'll turn it over to Pete.
Okay, thanks, Dan, and hello, everyone. So I'm going to be covering a couple of interesting observations that we're seeing with GO16. I'm going to start with the Florida sea breeze, and I'm also going to talk a little bit about some wildfire applications with the GeoColor. So we'll start with the Florida sea breeze. This is our primary convective initiation boundary that we have in the summertime here in Florida. We don't tend to get cold fronts that time of year, so we rely on the sea breeze to give us daily convection. And just as a quick review, the sea breeze exists basically because of the temperature difference between the land and the sea. When we heat up the land during the daytime and it's much warmer than the sea, we develop a broad circulation where, relatively speaking, lower pressure develops over the land, air rises, and then we have sinking air over the ocean, and a force directed inland, which results in onshore flow at low levels, and we see a kind of a westerly component to the flow aloft. And so what's often taught about sea breeze circulation is this broad circulation that appears to exist to drive the sea breeze. And of course at night, when the land becomes cooler than the water, it reverses and becomes a land breeze. However, what we've seen on satellite, older satellite, and even more so with GO16, has been what appears to be a tighter, more compact circulation with the sea breeze boundary itself, where we have lift above the convergence along the boundary, and then immediate sinking right behind this apparent boundary that exists. And we note this from clearing skies on the backside of the sea breeze, even over land, despite the fact that behind the sea breeze it's as unstable or more unstable than ahead of it. And so I'll show you that here in a moment. So we have the sense of a more of a tighter circulation, similar to what you think of with the frontal boundary, that is dependent on stability and the strength of low-level convergence with regard to depth and intensity. But this is kind of a key focusing mechanism for convection for our area during the warm season. So here I'm showing an example, and actually you see more than just sea breezes that come from the oceans. We also have breezes, if you will, that come from large lakes and rivers. We have river breezes. This is the St. Johns River in northeastern Florida, and you can see kind of clearing around it from a breeze of sorts, and then another around a large lake. And we see that with also other large lakes as well. And I'm going to focus, of course, on the coastal sea breezes, the one that comes from the Atlantic, the East Coast sea breeze, and the West Coast sea breeze that comes from the Gulf of Mexico. You'll note on this image, right behind or to the east of the East Coast sea breeze, it is dead clear, not a cloud in the sky. And given that earlier conceptual model of this large-scale, broad circulation, I would not have anticipated this, especially since conditions just east of the sea breeze are as unstable or more so. The temperature might be down a little bit, but the dew point usually is higher, with the air being more mixed further inland. And so it would be at least as unstable, so why would we not see cumulus clouds on the east side of it if we weren't having some form of subsidence? So I want to show you some soundings ahead of or before the sea breeze passage and afterwards. And of course we're limited to 12Z and 0Z, but I caught some days where the soundings were fairly representative. And so this is an example of what we see in the cool season on an unseasonably warm day where it's much warmer than the ocean, and we get a sea breeze in. But we're generally relatively stable, and so we don't see convection. We might see a little cumulus, but that's really about it. And you see in this example from Jacksonville the morning sounding ahead of the sea breeze with southerly surface flow, and then late in the day with the 0Z sounding toward evening with the winds more southeasterly, behind the sea breeze, not any less stable than beforehand, although in this particular example it is a little bit drier low levels than we see at the 12Z sounding. I'll show you a better example in the warm season where it's a bit more dramatic as far as instability. So here's July 5th, which is the case I'm going to focus on here. So the morning sounding, we actually have southwesterly low-level flow, not very strong. But notice in the evening sounding, this is at 0Z after the sun's starting to go down, with more of a south to south-southeast wind, sea breeze is to the west of the airport, and we see at least, if not more, unstable behind the sea breeze. And then further south, even more dramatic from Cape Canaveral, notice the afternoon sounding, or the evening sounding there with easterly flow, really unstable conditions there in the wake of the sea breeze, and yet the skies are clear. So the case on July 5th was one where we had generally a deep east to northeasterly flow over the area with high pressure over Alabama and southwest Georgia aloft. And so you'll see on the soundings, you saw the soundings there from July 5th, all the winds are aloft were east and northeast. And so here was the boundary itself. I'm going to kind of go through some images. I wish I could actually show an animation, but GoToMeeting generally doesn't allow us to do that very well. So I'm just going to show you a few static images. If anyone's interested in the actual animation, I can share that. Pretty interesting in 5-minute imagery. I haven't yet seen a case with 1-minute imagery, but I definitely want to, because you start seeing what appears to be this three-dimensional circulation in the vicinity of where the boundary is. So we'll look at all these boundaries here as I go through it. So we'll start here in the morning, where we already start to see a west coast sea breeze there. You start to see a cumulus line there starting to press inland, and not a lot of sign of the east coast sea breeze. There's also an interesting boundary that you see well offshore, which I'll point out to a little bit later. But so as I move forward in time, and you'll see the cumulus develop, and you'll see the sea breezes both sides moving inland. You'll see the river breeze here with the St. John's as well as they progress inland. Notice again, zero cloudiness on the eastern side of the east coast sea breeze. Not much on the west coast, although there is a lot of cumulus kind of streaming back towards the southwest. If you remember, I mentioned that the flow aloft is basically east to northeasterly, and so that top part of that circulation, which would normally have a westerly component, in this case has an easterly component, so not much for the east coast sea breeze, but it actually is pushing the cirrus and some of the cumulus stuff back towards the southwest. And then here we see, I think this is the last one right here. You also note that the convective activity is on the west coast sea breeze, and just some cumulus, but not really any real active cumulus or towering stuff on the east coast sea breeze. So with onshore flow, with an easterly flow, generally that favors the west coast sea breeze. That's where the convergence is more substantial, where you have easterly surface flow meeting southwesterly surface flow behind the sea breeze, whereas for the east coast sea breeze, it's easterly flow meeting easterly flow, so the convergence is much weaker. If we had more of a southwesterly flow pattern, where the reverse would be true, we'd see more of the convection on the east coast sea breeze. So this is my very poor artistic skill here, trying to show a three-dimensional pattern. Of course, it's very difficult to do, but essentially what I'm trying to show is for the east coast sea breeze, air ascends right where you have the convergence zone, and then wraps back and immediately descends behind it. So there's this tight circulation that appears to occur. When you look at the animation, you can actually see this kind of corkscrew-looking pattern of air quickly rising, going across, and then sinking behind the sea breeze. On the west coast sea breeze, of course, is in the opposite direction. And then you have this boundary that's offshore, and I don't know what that is, but you see the same kind of corkscrew pattern with it, with this flow, kind of a cyclonic pattern with air rising above the convergence zone and immediately sinking, but not necessarily clearing away all the cumulus behind it. So pretty interesting stuff that we can see. There were hints of it with the old GOES satellite, but with the higher resolution, both spatially and temporally, it gives us a little bit greater sense of kind of the structures of these features, which is kind of critical in terms of convective forecasting in our area. So again, from this conceptual model that's on the METED site that generally focuses on this broad circulation that exists, that satellite seems to suggest a tighter circulation local to the immediate boundary with ascent above the convergence zone and then immediate descent behind it. Any questions on that part before I go into the other part of this talk? Anything on the sea breezes? Okay, hearing nothing, I'm going to move forward on a use of GeoColor, and I don't know if there have been prior talks on this or not. My understanding, which I guess wasn't very good, was that GeoColor was interesting in that it showed how the Earth and the sea looked if you were to actually be up in space looking down. It kind of had the green-brown pattern of the land and the blue and even the clear blue waters of around the Bahamas. So it looks more like the actual Earth that you're looking at. But I didn't know if there's actually any meaningful operational value to GeoColor besides that compared to our other ABI channels. But it turns out that for wildfires, it's quite useful. Just as a reminder, the GeoColor basically uses an algorithm that incorporates the red band, the blue band, and the veggie, which is a simulated green, to show the realistic land and ocean color. The other thing I was going to point out is that one of the values of GO16 is that we have this spectrum of energy that we can detect different things from. So, for example, in the visible range, we have the band 2, which is the higher horizontal resolution, and yet other bands, such as band 1, despite lower resolution, might be better for other features such as aerosols, dust, and smoke. So even though band 2 might have higher horizontal resolution, it may be slightly better to see smoke plumes using band 1, or, as I'm going to show you here, using the GeoColor display. So I'll show you an example here first from March 3rd of 2018. And I'm going to start with the band 2. And if you look closely, you can probably make out the smoke plumes. There's one in the eastern panhandle, others in southern Florida, and there's hints of other ones around that I'm using the cursor to point to, Arkansas, Missouri, parts of Mississippi. In fact, there's actually fires all over the place. And a lot of them, the smaller ones, are hard to see here. If you go to band 1, again, lower horizontal resolution, but still better as far as trying to detect aerosols and things like smoke, you now start to see a few more here in Alabama, a few more plumes in southwest Georgia, northeast Georgia, starting to appear a little bit better, along with the ones here I've already shown in Florida. But compare that to the GeoColor, which I will show now, and the smoke really stands out. And you can see even really small fires in South Carolina, other ones, very small ones here in east central Georgia and southern Georgia, smaller ones elsewhere in the panhandle, across southern Mississippi and Alabama, and so forth. Pretty interesting how well that shows up on this display. Another useful feature in GO16 is the fire temperature, RGB, as far as looking for hot spots. In this example, you see several of them. There's a couple you see here in Florida. You see a couple in one in Alabama, one in Mississippi, and Arkansas. Interestingly, is that if you zoom in, I'm going to try and do that here. If you look closely enough, you actually see other dots, albeit much smaller scale, that seem to appear also where we have smoke plumes. There's a small one right here. I think we have smoke plume in the part of the Florida Panhandle. Some other very small ones here in southern Mississippi. So pretty fascinating that we can see this. So I'm going to show one other case, which is 5 days later. We had more fires. Again, I'm going to show you the band 2, the higher resolution visible image. See if you see any smoke plumes. Your eye probably will first turn to this area of low pressure that you see curved cloud pattern here east of South Carolina. Also a jet streak over the Gulf of Mexico. But if you look for smoke plumes, they're very difficult to find. There's hints of them around. There might be one here, a couple hints of them, and maybe some also up in Missouri. If you look at band 1, they stand out a little bit better here in Alabama, some in Mississippi, also up in here in southwest Missouri, parts of Arkansas as well. But I still think if you look at the GeoColor, they stand out much better. And you even start seeing small fires in southwest Georgia, southeast Alabama, southern parts of Alabama and Mississippi, and so forth, as well as the larger ones. Even the smoke plume here in eastern Georgia, which was hard to see in the visible images, it stands out much better. And again, here's the fire temperature one again showing some of the hot spots pretty clearly. And again, if you zoom in more, you will find even a couple of these smaller fires as well. And I think that's really the end of what I was going to show. It's just an interesting utilization of the GeoColor, just beyond a better representation of the Earth's surface. And that's what I have to present. I'd be happy to answer any questions you have.
Hi, this is Scott. Thanks, Pete. That was nice. And I'll just say that if you want a mezzo, you just have to call it. So there must be some time this summer when there's not much weather going on and you have easterly flow, and you could just request a mezzo over you then just to get the 1 minute imagery.
Yep, I think we will do that. We'll try and do that at some point over the summer when there's not much other severe weather, and see if we can get a couple good cases. That's a great idea.
And Pete, this is Dan. Have you had any success using the split window difference product to analyze imminent convection along the sea breeze?
No, but I haven't really looked closely at that, so I can't say for sure. That's something I think we should start looking at, but that's not something we've started yet.
Okay.
Yep.
Any other?
Yeah, hey, it's Brian.
Yeah.
Yeah, Florida's kind of famous for super fog, the fog that combines with the smoke.
Yep.
And I'm wondering if you've had any cases of that lately and how that showed up in GO 16.
We've not had any cases of that, but that's something I definitely want to focus on when we do have a case. We've had a lot of dry air surges this early this spring, late winter, so we haven't had any really good cases of it. But I think that we're having a really good fire season so far, so I think we'll have some opportunities over the next month or two to see if we can get some higher resolution stuff, or higher temporal resolution, and see what it's shown when we have fog smoke mix.
Okay, yeah, we'll be on the lookout for that. I think that'll be great. That'll be good.
That's a serious concern for Florida Highway Patrol.
Right. And how did things go with the MDS request yesterday?
Well, so that was interesting. I saw that it was available. You'll recall one of the things I've said in the past is how overwhelmed we are data-wise. So
right.
In the middle of the event, I don't know if anyone actually ended up looking at much of it because there's just too much. I looked at it a little bit, and it was interesting to look at some of the boundaries that occurred and how the initiation kind of evolved. But God, it's tough in the middle of an event to have staff to have someone focus on looking at things in 1 minute interval as opposed to just getting a quicker picture over a 30-minute period using 5-minute imagery.
Right. Yeah. Once you're in the heat of battle, it's tough. The other thing that happened was there was another request submitted in the middle of your request.
Yes, I saw that, and I don't know if I don't understand a value of 30-second imagery as being greater than 1 minute imagery. So, in that particular case, there'll be no impact as far as having that second one put into place and having us go to 1 minute imagery. I don't fully understand what the negative impact would be of that, going from 30-second to 1 minute, given how impressive 1 minute imagery is.
Right. It obviously would give you twice as much imagery, but if you're challenged to, with the 1 minute, then it would seem like it'd be doubly challenging. And on the research side, we've seen it depends what you're looking for. Mm-hmm. If you're looking for low-level boundaries or new boundaries that are maybe coming out of a storm, you might see those better or sooner, have more continuity with the 30-second imagery. And if you were looking if you had a thunderstorm that was going to move over a boundary or maybe ingest a low cloud, you might see that better in the 30-second imagery as well.
Did you guys have any kind of way of archiving that data?
I'm sure we have it somewhere, if not in multiple places.
It would be useful to be able to go back and review it. We had a very interesting case yesterday of dominating left movers and lots of hail, including golf ball here at the office here. Some interesting structures that I think would be interesting to look at from a 1 minute perspective to try and interpret.
Yeah.
We just didn't have the staff to do it yesterday.
Yeah, we can definitely work with you on that. That whole system's history had some pretty impressive hail with it.
Yeah, it did.
I'll save the data here, and I'll let you know, Pete, when I have it.
Okay.
For you.
Thank you.
Any other questions for Pete?
I just have one more comment on the fire RGB. I've talked to OPG a little bit about this, but if you zoom in, you'll notice that the hot spot in the fire RGB is offset by a pixel or two from the 3.9 micron. So the 3.9 micron has the correct location. Don't use the RGB to geolocate stuff. They're looking into why that shift is there.
Okay. I'll tell you though, it is really fascinating to watch the RGB to show the hot spot and then immediately see the smoke plume after that. Even for small fires, I think that's pretty impressive.
Yeah.
Okay, any other questions for Pete? All right, I'll turn it over to Brian for any general questions.
All right, thanks, Dan. Let's open it up and see if anybody has any questions about GO 16 or mesoscale sectors. Anybody out there want to ask a question?
This is Ron in Spokane. I'll actually ask a question about GO 17. I know that it was a successful launch, and I believe I had seen that they were expecting to have a one-year checkout like they did with GO 16, but I haven't seen anything as far as an approximate timeline of the expectations for the checkout.
Okay. Yeah, Ron. This is Brian. So if you go to the store on the VLab, we have the post-launch test checkout chart there, and that has the milestones. The data should start to flow sometime this summer, and we can get you exact dates once those get closer.
Okay, I'm going to the store. Okay, I see the figure that you're talking about.
Yeah, there's one on the top right. It's for GO 16, and on the bottom right, it's for GOES S, which is now GO 17.
Right. So sometime this summer, data will start trickling into AWIPS.
Right.
And it
I
will
think it's
move to its final resting place sometime this fall.
Yeah, they're gonna truck it to the west probably as soon as they can, given the status of GOES 15. So, yep, that's the plan.
Okay, thank you.
But much like when they moved GOES 16, when they're actually in transit, you can't get the most of the data and imagery. So that's one part of the relocation is losing the live data for a little bit. Okay, anybody else?
Yeah, hi, this is Steve in Charleston, South Carolina. I appreciate the presentation, Peter. Sea breezes are near and dear to our hearts up here in Charleston as well. I have a general question about the mesosector request process. My impression is that this is being left up to individual regions to how to handle this. And what we do here at Eastern Region is we submit a for the record, which is, people are pretty efficient about it, but there's an entire form you have to fill out in order to request a mesosector, and folks here have been very efficient about it, but it seemed like the old method of, calling the central office. We used to call Pittsburgh back in the GOES 13 days, and prior to that we used to call them for rapid scan operations and so forth. Does anyone have any insight? Can anybody give me any, are there any plans about making this, changing the process, maybe making it a little more efficient, or have we pretty much settled on this method as far as requesting mesosectors?
All right, excellent question. We are looking at each region and how they're handling the requests. The common thread seems to be that they want the request to go through the ROC. So you may have dealt with either the ROC duty officer or Dave Riddell if you've made a request recently. So we're working with Dave. We're trying to coordinate with what Eastern Region is doing and Southern Region. We're interested to hear if you have any issues or problems. The main one of the main things about the current standard operating procedure for the requests was that it was arrived at mostly by NESDIS people, so it takes the NESDIS ConOps and their operations factors into account. It doesn't take as much of the Weather Service ConOps into account, so we're trying to make some changes. The operations group at Weather Service headquarters, Mike Betley and others there. He's the MIC of the National Operations Center, the group that you probably see the significant weather messages and the briefings that we send out to leadership and management by email. He's going to be looking and forming a team to better address the Weather Service operational concerns as it relates to the mesoscale requests. So we've been working with him to try to make him aware of some of the cumbersome from the Weather Service side parts of the current process. So that's a long-winded answer to say that they're forming a team, and we hope to make some changes to streamline the process. And if you have any input, you can either go through Eastern Region, or you could send your comments to me. I'm Brian Mata.
Okay, I appreciate the heads up about that. The system's working fine. It's not that it's not working, and our office has been very active about requesting mesosectors for a variety of weather situations, and it's worked very well. I kind of have my eye on operational efficiency. That's kind of a big thing for me. So if there was a somewhat more efficient way to do it, I think that might help us out. But it sounds like you folks are looking into that, and it's great to know. Thank you.
Yeah, and what's more interesting is when GO 17, starts flowing data. The SDMs are going to have to manage 4 mesosectors. So we're trying to aim for some kind of updated training in that time frame when GOES West MDSs become available. Okay, any other questions today?
Hey, Brian, this is Mike from Corpus Christi. I had a question about the GLM lightning data. I was wondering, when do you expect that to be in AWIPS? I know the sport group is going to do an assessment this spring, but I haven't heard anything recently.
Right, excellent question. So the GLM data has been flowing over what's called the GRB satellite feed, the GOES-R rebroadcast. It hasn't made it to the SBN yet, the AWIP Satellite Broadcast Network. The hazardous weather test bed is going to take a first shot at using a gridded GLM product this spring, and in parallel with that, both I think it was Southern and Eastern Region were urging that we not lose another convective season without making the data available to the WFOs. So what's going on is that there's the Office of Observations has a developer group, and they're creating a gridded GLM image that they'll be sending either initially via LBM but eventually over the SBN to all the field offices. So the hope was to have something in the next week or two in the way of a grid that people could start evaluating. So initially it'll go to a few WFOs in the hazardous weather test bed, and then as quickly as possible, I wouldn't promise an exact date, but sometime in the the June time frame, it should make it out to the rest of the field. So that's the current plan. The reason it's been delayed is there were a number of data quality issues, and we're in what's called the eclipse season right now, which is where you can have solar intrusions into the telescope of the GLM, and that basically creates lots of false data, and they didn't really have a way to control that, and there was some concern that if it was put on the data circuits, that it would overwhelm the bandwidth or the ability for AWIPS to absorb all that data. So it's a new sensor, and there are some things that were foreseen and some things that were unforeseen. But you can still access some of the imagery and some of the lightning data through SPORT, as you mentioned, and also at the University of Wisconsin, they have a viewer called Real Earth, and some of the imagery is on there as well. All right, one more time. Any other questions? Going once? Going twice? Okay, thanks. Have a good day.